Or the physiology of learning. The vid7 Sansi Theater at gmail.com. All right. Look at this. Yeah, that is our poster. That is the vid7 Sansi Theater. Yeah. Don't forget to like, subscribe for more and better videos. Our channel has a lot of good videos you can enjoy and share. Okay. Learning and its forms. Learning is just a neural mechanism by which the individual changes his or her behavior on the basis of past experience. That is learning. And it can be incidental learning in which behavior change is not immediately apparent. For example, we have non-associative and associative learning. That is incidental, not immediately apparent. Then we have reflex learning, in which the learning is associated with an immediate behavioral response or change. Okay? So let's talk about non-associative. This is one form of incidental learning. So here the subject learns about the properties of a single stimulus. It results when an animal or person is repeatedly exposed to a single type of stimulus. So in non-associative, you just learn about a single stimulus after repeated exposure of the same type. And non-associative can be habituation or sensitization. So I've gone further: incidental, non-associative, habituation, sensitization. All right. So let's talk about habituation. Habituation refers to the decrease in response to a benign stimulus when the stimulus is presented repeatedly. Here we have a decrease in response to a single stimulus which is repeated in fashion. Okay? So when the stimulus is applied for the first time, it is novel and evokes reaction. This response is called orientation reflex. Oh, what is it response? What is it? All right. So that is the first response that occurs on first exposure. So, however, due to habituation, less and lesser response is evoked on repeated stimulation, and eventually the subject totally ignores the stimulus. This is what we call getting habituated to that very stimulus. All right. So, cellular basis of habituation. Habituation is associated with a decrease in neurotransmitter release at the synapses, which in turn is due to inactivation of calcium influx at the axon endings. Influx of calcium via the presynaptic membrane is reduced, causing habituation. So, presentation of another stimulus, usually a noxious stimulus, results in recovery of habituated response. This is called dishabituation. If you introduce pain, you can dishabituate and the individual goes back to restart on the what is it response. Okay? So let's talk about sensitization. Maybe habituation, I talked more about it, the causes and the properties of properties of synapses, synaptic transmission. There you see more about habituation. A video is also on our channel. You can subscribe and watch it. So sensitization is the opposite of habituation. In it, repetition or repeated application of distinctly pleasant or even unpleasant but strong stimulus will produce greater and greater response. What am I meaning? An animal can respond more vigorously to a mild tactile stimulus after it has received a painful pinch. Yeah, this is a good example. After a painful pinch, a mild stimulus can also evoke more response. Okay? So, NB. A sensitizing stimulus can override the effects of habituation, i.e., cause dishabituation. This we've seen. All right. Let's talk about the cellular mechanism of sensitization. 1. It is associated with increased release of neurotransmitters from axonal endings of sensory neurons. This result is due to presynaptic facilitation. This is the major reason. Presynaptic facilitation of synaptic transmission, but about by a third neuron, which we call as a facilitator neuron. Yeah, this facilitator neuron is the reason we have sensitization. so that the transmitter released by presynaptic interneuron. The neurotransmitter is usually serotonin or 5-hydroxytryptamine. Okay, that is released by the facilitator neuron. So let's talk about associative learning. Here the subject learns about the relationship between two stimuli or between a stimulus and the behavior. Okay, so look at this. There are two forms of associative learning, and they have been distinguished based on the experimental procedures used to establish the learning. For example, we have classical and we have operant conditioning. These are the two forms of associative learning. Let's talk about classical conditioning. Here, it involves learning a relationship between two stimuli. And if you learn a stimuli and behavior, that will be apparent. So in classical conditioning, you have learning between two stimuli relationship. So classical conditioning is also called Pavlovian conditioning, or conditioned reflex type 1, or respondent conditioning, or type S conditioning. All these are names of a single word here up here. So the characteristic features of a classical conditioned reflex are: 1. As a reflex response to stimulus that previously elicited little or no response, acquired by repeatedly pairing the stimulus with another stimulus that normally does produce the response. So you get a stimulus which is capable of producing response and one which won't produce response. So the one which you won't produce response, if you associate it with one which usually produces a response, you get a result of a response. So in classical conditioning, a temporal association is made between neural-conditioned stimulus, neutral-conditioned stimulus, and an unconditioned stimulus that elicits an unlearned response. So this is a good point to note. And 3, reinforcement. Look at this. Following a conditioned stimulus with the basic unconditioned stimulus is a must for retaining a conditioned reflex. Otherwise, it will extinct. Okay, so you must maintain it, because if you don't maintain it, the unconditioned the conditioned reflex will do what? Will extinct, will disappear. Okay, so physiological basis of conditioned reflexes. Physiologically, the occurrence of conditioned reflexes is explained by the formation of new functional connections in the nervous system. New functional connections in the nervous system. So, for example, in experiments of Mr. Pavlov, salivation in response to the ringing of a bell indicates that a functional connection has been developed between the auditory pathways and autonomic centers controlling salivation. Yes, autonomic nervous system and auditory pathways, there have been a connection made so that the dogs will salivate on a ring of a bell when food is absent. Okay, so site of formation of functional connections can be intracortical and also can be subcortical. All right, so evidence for that. Evidences in favor of intracortical level are: in animals that lack cortex, in the corticate animals, the conditioned reflex can be built up with great difficulty. Presence of sensory cortex is a must to understand a complex sensory conditioned stimulus. So these two are evident of fact that intracortical functional connections are made. Okay, so let's continue. Evidences in favor of subcortical level. So non-discriminative conditioned reflexes to simple sensory stimuli can be formed in the absence of whole neocortex. All right, so simple sensory stimuli. I love that word. You enjoy. Okay, let's continue. So let's talk about the experiment of Mr. Pavlov. in which he was explaining classical condition reflex. When food, this is the unconditioned stimulus, is presented to a hungry dog, salivates. When food, the unconditioned stimulus, is presented to a hungry dog, it salivates. This is the unconditioned response. Or if a bell is rung, this is the conditioned stimulus. Just before the food, the unconditioned stimulus is presented. The dog learns to associate the conditioned stimulus to unconditioned stimulus. All right? So the conditioned stimulus is the bell. Unconditioned is the food. Salivation is the unconditioned response. Okay? So eventually the ringing bell alone causes salivation. Of course, if the food fails to appear consistently when the bell is rung, the conditioned response fades away, a process called extinction, or what you can call internal inhibition. Thus, a conditioned reflex needs to be reinforced frequently, otherwise it dies out. Okay? So operant conditioning, let's talk about that. This is also termed as instrumental conditioning, type 2 conditioning, type R conditioning, or try and error conditioning, and it involves associating a specific behavior with a reinforcement event. And operant conditioning is of two types. One can be of a reward. In it, a naturally occurring response is strengthened by positive reinforcement, which we call a reward. Or it can be aversive conditioning. Natural occurring response is weakened by a negative reinforcement, call it a punishment. So those are the two forms of operant conditioning. The experiment to demonstrate operant conditioning is here. When you get a hungry rat and place it in a cage with a lever protruding into the cage, such that if it touches the lever, something happens. So, because of innate response, the rat will randomly press the lever. That is innate. So, if the pressing of lever is not associated with any event, the pressing of lever will be at a given rate or random rate. But if the pressing of lever is associated with a reward, the rate of pressing the lever will be much more than the random rate. This is what we call reward conditioning. But if the pressing of the lever is associated with a negative reinforcement, call it a punishment or electric shock, lever pressing rate will be much less than the random rate, aversive conditioning. Right. Interhemispheric, so that is aversive conditioning, reward conditioning, and the random rate in absence of any reward or punishment. So let's talk about interhemispheric transfer of learning and memory between two hemispheres. Much information is transferred between the two hemispheres through the corpus callosum, although some is transferred through other commissures like anterior or posterior or hippocampal commissure. So failure of intercortical transfer of learning and memory is seen in human patients who have had surgical transection of corpus callosum to prevent interhemispheric spread of epilepsy. So when they are preventing epilepsy, they transect the callosum corpus. So here we see failure of intercortical transfer of learning and memory. So studies in subject indicate that this transfer of visual memory occurs in the posterior part of corpus callosum, while transfer of auditory and somatic memory occurs in the anterior part of corpus callosum. So there is a transfer. If it is audition, it will occur in the anterior part. Hospital or visual information will be transferred in the posterior part between the two hemispheres. So don't look at this. Look at this. A transected corpus callosum has yielded the following result. The right hemisphere specializes in spatial task, facial expression, body language, and speech into notion. Okay? But the patients with the transected corpus callosum lack coordination. For example, when they are dressing, one hand may button a shirt while other tries to unbutton it. So this shows uncoordination. if you transact corpus callosum. Okay, so from this very experiment, I can conclude that the two hemispheres can operate quite independently when they are no longer interconnected. All right, so don't forget to like, subscribe for more and better videos.